Mozilla Hacks, an intro to A-Frame. So I've been working on this module series, this workshop series, a series of modules, on a bunch of different topics. And the idea is that this should be simple enough for anybody to work through on their own or for a teacher to use as the basis of a workshop. Even if you haven't used A-Frame before, it should give you enough that you could put on a workshop. And I've got some notes here. The modules we got so far is the introduction to HTML, WebXR, and A-Frame, then basic geometry, audio, lighting, images, and physics. Today I'm going to skip images and physics and audio because they all use large files, which just aren't going to be very appropriate for a 13K competition. Physics doesn't use any resources like MP3s or big images, but the physics library itself is pretty large. So we're going to start with our introduction to HTML, WebXR, and A-Frame. We're going to go through and build our first thing. So the first thing I want you to do is open up this web page. This is a glitch. So a glitch is a live coding environment, and it has this really cool thing where one person can create a glitch. Here's a simple web page. You can then go to this glitch, click Remix on Glitch. Now it is making a copy for you. I like that they use the word remix instead of fork, because remix to a person who hasn't been a programmer for years and years, remix makes a lot more sense. The way it works is, every time you type here, this is HTML, as you undoubtedly know. Make this a little bigger. Now I can see a live version in this tab over here. It says Hello World. Now I'm going to go back and say Hello Universe. And when I flip back over, it has already updated. So it's this live environment where you can create anything web-based and immediately see what you're working on and immediately share it with other people. It's all on its own website. So in this case, it generated one called colossalhedge.glitch.me. It's all secure. You don't have to worry about setting up certs or any of that stuff. It just works beautifully. So I've been using Glitch for all of these workshops. Now, if you haven't done HTML before, I'll show you, like, this is header 1, which then becomes this big text right here. Each one of these P elements is paragraph, which is P stands for paragraph, and each of those becomes something here in the final document. And so if I was to add something, I want to build a cool game too. Now when I flip over, we'll see that paragraph. So everything here in my source document goes into my final document. Now, let's take a look. Let's do the same thing, except I'm going to paste over it with our A-Frame project. And now we can see here is a red sphere. So we'll ignore this for now. This just sets up the page and imports A-Frame. Hide that. We can see here's a scene, and inside the scene is a sphere, which is radius 1, color red, and that's the position. Let's make it bigger. I'm going to set radius 2. Flip over. That is a very nice, big sphere. Let's change the color. How about tan? T-A-N. Yep. And you can see it's already got lighting set up. I can already move around. Now let's suppose we want to add another sphere. Just create another thing here. A sphere, radius equals 1, color is, let's make it aqua, the position. Now, position is important. So the position is actually 3 numbers in 3-dimensional space, x, y, and z. If you remember from math class in school, you have the x-axis and the y-axis, where the x-axis goes left to right and the y-axis is up and down. Well, we have a third one now, the z-axis, which is into the screen or away from the screen. And for various historical reasons, a negative value is into the screen and away from the screen is a positive value. Since we're looking into the screen, let's set it to -4. And of course, our other sphere is right in the way. So let's move this sphere off to the left, which would be -2, and move our new sphere off to the right, which would be +1. And you notice I said this is 0, 0, and it's actually below me. Well, that's because the camera is not at 0, 0, 0. It is at 0, about 1.5, 0. So a height of 1.5, because these dimensions are actually in meters, and it assumes that you're standing up, and the average height is somewhere around 1.5 meters. So there we go. That looks a little better. So that is actually all there really is to A-frame. You create these objects, and you can do cool stuff with them. So let's head down to covered position. Oh yeah, color. So we can change the color. You can use any color you want. It understands all of the CSS color names. So red, green, blue, yellow should work. Yep. Probably even like goldenrod, which is one of those weird orangey yellow colors. And of course you can just use hex values if you want. So I could do FF00FF would be magenta. So anything you would use in CSS you can use here. We can also set the background of the entire scene. Right now it is white. We can set background to color red. And that would be, very hard on the eyes. Let's set the background to tan. How about that? Yeah, that's a little less offensive. And let's set this to, let's say, teal. There we go. Much nicer. Now, we've got spheres, but we can do other things like cubes or boxes. So a box. Again, let's set the position to 0, 1.5, whoops, -4, because if I could put the position at 0 for the Z, but then it's actually at the camera, which means I wouldn't be able to see it, because it's actually too close to me to see. So, let's say -4. There's our white cube. Let's give it a different color. Teal, and let's give it a width. Let's make it a little wider. So 2, height is 0.5, so it'll be really skinny. And then leave the depth at 1, and we can even rotate it to, let's see, 0, 0, 0. Let's rotate around the y-axis by, let's say, 45 degrees. Whoops, not rotate, rotation. There we go. So that's a box. And again, we could add as many of these guys as we want. So if I wanted to build something out of boxes and spheres, it's pretty easy to do. For example, if I want to create this Mickey Mouse shape, I just add a couple spheres, position them where I want it to be, change the colors. It works nice. And there's a bunch of other shapes. There's cones, cylinders, and in fact, let's go take a look at the A-frame website. aframe.io. Let's go to docs. Now, the A-frame website has some really good getting started tutorials. A lot of examples of all the crazy complicated things you can do. I want to go down to the docs here. These are all the standard components. Let's look at, let's see, we've got the box, which you've already seen. We've got a circle. Now, a circle is different than a sphere. A circle is an infinitely flat circle. So if you tried to look at it edge on, then you wouldn't be able to see anything. It's used more for things like signs, or if you want the floor of a surface. We got cones, cylinder. Ooh, let's do an a dodecahedron. Let's copy that over. Let's add a dodecahedron here. We'll give it a position of 0, 1.5, -4, and dodecahedron. Now, that might actually be too big. Let's back it up. There we go. Whoa. Dodecahedron. Pretty cool and ginormous. What else we got? Icosahedron, octahedron, the plane, which is just a giant rectangle in space, a true ring, a torus, tetrahedron. Ooh, torus knot is extra cool because you can set some parameters and get all sorts of funky things. Set up our torus knot. You can say how much of an arc it should be, the radius of it, and the radius of the tube part. Set its color, position. Let's get rid of these guys. Let's see what our torus knot looks like. Whoa! That is a pretty cool shape. And if we change these two Q and P parameters, let's change that to 3, and you can see the type of shape changes. And that is a very strange looking donut, about 7.1. Whoa! So with very little code, you can get all sorts of cool, crazy shapes. Let's try 1.2. Ah, interesting. I think only integers will make the ends lined up. So yeah, torus knot is pretty sweet. So all of those are built into A-frame, so you don't pay anything extra to use those. All right, let's get on to the next workshop. So we talked a little bit about geometry, you know, cylinders and cubes, and the way A-frame works, everything is an entity. I'm using here like a sphere radius equals 1, color is red, and the, whoops, position 0, 1, 1.5, -5. This, okay, back to our sphere. Let's look at the underlying geometry, because it's not actually a sphere. Computer graphics cards can't render a true sphere. At some point, it has to turn that into a series of flat surfaces, usually triangles. So what we can do is this. Whoops. Is that wireframe? Oh, I have to say wireframe equals true. True. There we go. So now we can take a look at the actual underlying geometry. You can see it's made up of a whole bunch of stuff. And in fact, it will let you, you can adjust how it subdivides the underlying surface into those triangles. So in the case of a sphere, we can say, segments, that's the word I was looking for, segments. So right now we can see the default is to have 18 horizontal segments and 36 vertical segments, which gives it this mostly smooth looking sphere. But maybe I want a really pixelated, you know, kind of a retro low poly style. So let's set segments width to 10 and cut it down. Let's try 8. Whoops, what am I missing here? Segments width is 8. This says, oh, right. There we go. Segments width. Sorry, when we're doing it as an attribute, it's got to be lowercase with a dash in the middle. So now we can see that it cut down the total number of segments. Horizontally, segments height, set that also to 8. Now it's a much more low poly looking sphere here. So you can adjust the underlying geometry, which can be very useful depending on the kind of effect you're getting. And if you want to look at the geometry for any of these, just add wireframe equals true, and you can see what's going on underneath. Now, in A-frame, most objects are 3D, but some are, in fact, 2D. Yes, you really can have a 2D object in 3D graphics. They are just infinitely thin. So if we take a look at this little demo, come on, there we go. You can see when it gets to the edge, it is infinitely thin, but you don't notice that. Now, if you do notice that your object disappears when it goes around and then reappears if it continues all the way around, then the problem is that you now are using a one-sided, you are now using a one-sided object. Bring back my lesson. There we go. So make sure that you turn on both sides, basically. And the way you do that is with, let's see, inside out, spheres, triangles. No. Here we go. You set side equal to double. You can set side to front or back or double. For these two-dimensional objects, you can determine which side you want to actually be drawn. Now you might wonder, well, why would you ever want something other than double side? You might be going for a special effect, or it may simply be that no one's ever going to look at the other side, so it makes sense to not ever draw it, just because that's less polygons for the computer to process, and therefore your project will run faster. Like if you're making a floor, as long as no one's ever going below the floor, then you don't need to draw the bottom of the floor. And every polygon helps. Okay. Now you can also import 3D objects in the GLTF format, and GLTFs are pretty slim for containing full 3D geometry, but it's still difficult to find some that are going to fit under 13K even when compressed. So I'll just let you know that they exist. You can use the GLTF model attribute and a URL to the GLTF file. Though for this competition, if you are using one of these, this should be a local relative URL. And then you can look at cool stuff like this. All right, next thing we're going to cover is lighting. Now lighting is exciting because it doesn't really cost you anything extra in terms of bytes. Just to set up the light, but it can dramatically change how the scene looks. So here is a simple rotating cube. Now you'll notice, because of where the light is, that the cube looks darker on the right side than on the left side. And that is because there is a light set up here. Now by default, A-Frame will create some lights for you. So that's why we can see stuff even though we don't have any lighting turned on. But for this, let's go back to our nice little sphere here. If we turn off wireframe, there we can start to see a little more of the edges, but even though it's pretty low poly, it looks fairly smooth. Let's add a light. So we'll copy this out here. I'm going to add a directional light. Now the color of the light is white. You can have other colored lights, but it's good to start with white because then it shows the true color of the thing you're showing off, which in this case is red. So this light is a directional light, which means it exists in some point in space, but it's not really a single point. It's more like it's infinitely distant. So whether you move left or right, it's still coming from the same direction. Think like moonlight or sunlight, rather than, say, a light bulb, where you could get closer or further away from it, and the angle matters. So we give it a position, but really the position is actually a vector from the origin pointing in the direction that the light is shining. And this is a white light. So now we see we have just this one light, and the shadow is much darker than it was before. Well, that's because by default, A-Frame actually creates two lights for us. One is a directional light, and one is an ambient light. You see, in computer graphics, it only draws the lights that we add. But in real life, there's nothing that's ever truly in shadows. There's always a little bit of light, unless it's nighttime. And even then, there's still a little bit of light that's bouncing around the scene. But that's too difficult to model on a computer, at least in real time with the system we have available. So what we do is we add this ambient light component, which just means give everything and every surface, no matter where it is and what direction it's pointing, give it a little bit of light. So let's add in our ambient light here. Let's give it, where's the ambient? There we go. Okay, so we have a light directional with a position and a light ambient. Again, the color is white, but I don't want it to be full brightness. We just want to bump it up a little bit, so I gave it an intensity of 0.5. It doesn't have a position because it doesn't matter where it is. It's ambient. It affects everything equally. And now we can see in the shadow it still has a little bit of color. Often you will want to add, it's like a theater movie thing, you want to have two lights, directional lights, coming from different angles. So let's set this to -1. That's a little too even. Let's make it a little darker. Intensity equals 0.2. And let's move it to -4. Let's see how that looks. Whoops. Maybe get a little more of a highlight, move it around to, there we go. So now we have a little bit of highlight, and this is our main light, and then when our ambient fills in the shadows. So it looks a little more realistic. Okay. So those are the main 2 types that you're going to use. There's a third type that we use very commonly called a point light. Point lights are more expensive than ambient and directional, so only use them when you really need them. But if you want something that looks like, actually before I get into point lights, let's talk about immersive. So if we're going to build a scene like this, we actually need 2 things. We do want the angle to matter, so I'm going to use a point light where it has a position in space, and so this one is a little closer to this thing, this is a little further away, and the angle's more oblique, so it fades. And then, even though it's completely dark, we want this thing to actually glow at night. So that's what an emissive surface is. So let's come back here. Let's change the background of our scene to black. There we go. Let's create, let's make our sphere be a light gray. Get rid of that. Here is our light gray sphere. Now you'll notice we can still see it because we have some lights in here, the default light. But what we want is for it to actually glow a uniform light gray. There we go. Now it's actually producing its own light, and so it gives us a uniform color. Now let's add a point light, which will take away the default ones that A-frame gives us. So let's put in a point light here. By the way, sometimes I put the lights before the objects in my scene. Sometimes I put them after. It doesn't actually make a difference. The order that you put things in the document doesn't make a difference for how it shows up on the screen. It will always do the right thing. So here's a point light inside of where the moon is with intensity of 1 and a distance of 50. So that means it's anything that's more than 50 away won't show any light at all. Let's add our, where's my cubes? I had some cubes in here. Here we go. Let's just add a cube. A box. Position equals -1, 0, 1. Color is red. Why can I not see? Oh, whoops. I want it to be, whoops, -4. What that? There we go. Now we can see our cube is being lit here by the point light, but that's obviously way too dark. So let's give it a plane below. Let's add a plane. The plane is going to fill a lot of space. I made it width 40 and height 40. Now that may seem weird because height would be like up and down, right? Planes are actually up and down by default, so they're width and height, and they have no depth. But we want this to be on the floor, not a wall. So what we need to do is position it and then give it a rotation around the x-axis, which sort of folds it down. And that looks like this. There, now we've got our plane, and you can see how the point light is nicely lighting up the plane, and it drops off as the plane gets further. It gets darker and darker over there. And we're not even using shadows yet, and we've already got a scene with a lot of mood and a lot of complex lighting. Very little code. Okay, so the next thing we want is an actual shadow. Now, shadows are a little tricky because they involve three things. There is the light, which will be used to create the shadow, which is going to be the moonlight here. There is the object, which is casting the shadow, which would be this cube. And then there's the object which is receiving the shadow. And receiving means that it's the thing that is holding the shadow. Like the cube is going to cast the shadow onto the floor, onto our plane. So what we need to do is let's go to our point light. And where's our point light? Let's set cast shadow equals true. I don't need any of that. Just need to turn on casting shadows. And we don't see it. That's because there's another part. We've got to make the box do, it is shadow. Cast is true, right? And then we need the plane to receive the shadow. So shadow receive equals true. Did I misspell I before E except after C? Okay, what did I miss? Shadow, oh, whoops. It's not actually shadow cast true. It's shadow cast is true. Shadow receive is true. I forget the syntax all the time, so if you do, don't worry about it. That's why I keep the A-frame documentation open. And so shadow receive is true. Let's look it up. A light, attributes, there's the type. Oh, apparently we can't set up shadows with the A light. We've got to use the longer syntax. So something I've kind of skipped over, but we're going to have to dive into now. These things are shorthands. So when I'm saying a sphere, what I'm really doing is this. I'm saying a entity, and the entity has a bunch of components on it. One of those components is geometry. Mesh is sphere, I believe is what I want to do. And then I would say like material color is red. Then position. Oh wait, we're duplicating this one. So mesh is sphere, radius is 1. Colors are light gray. And emissive is light gray. Position is 4, 4, negative 4. And if I did that right, we should see that, except it is a box, which means I messed up my syntax. What we want is geometry, not mesh, primitive. See, if you're coding at the 3JS level, it would be called mesh, but we're using A-frame. There we go. So that previous sphere, what we're really doing is we have an entity, and it has all these components. And one of the components is geometry, which is all of the attributes which describe the shape. One is the material, which is the color of the object and how light interacts with it. And then one is the position. So we need to do the same for light. A entity, light equals, type is point, shadow is true, position, let's just get these here. Color is gray. Density is 1. Distance is 50. And make sure that tag matches up. Oh, I forgot this position. Equals 4, 4, negative 4. There we go. Okay, so here's my object. The light is projecting. We've got shadows turned on the cube, shadows receiving, so casting on the cube, receiving on the plane, and then sending it up. Now what's really cool is that these are all live. So if I was to do something like, let's add where's our little rotation here? I always steal from myself. So I wrote some code here, which makes this guy rotate. So now let's just go take a look. There we go. Now let's add some animation so this box will rotate. And there we go. And you can see how the shadow is completely live and updating, which looks really awesome. Now shadows are still fairly computationally expensive. There are things you can do. You can adjust like where the shadow falls to kind of reduce the computation. It's running perfectly smooth here on my desktop. It might not on my smartphone. So that's something to be aware of. Let's get rid of that. So that is the basics of lighting and shadows. If you want to dig some more into this, then you can find it on my GitHub at WebXR Workshops. I'm posting this in right here. Now, I'm working on the next workshop, which hopefully will come out this week, is on doing advanced geometry. And that's going to be very useful for this project, because with advanced geometry, instead of using just the primitives that we've been given, we can create our own shapes using math. So if you want to create this weird wavy surface that animates, you could do that. So that'll be coming in advanced geometry. In the meantime, on the A-frame docs, there is a demo of register a custom geometry, where you can create custom geometry and then use it just like we were using box. So in this one, for example, they created one called example, which then it goes down to the 3JS level to create some geometry using input data, and then creates all the faces, does all the setup, and sets it as a geometry, which you can then add to any other object, just like we would with the cube or the sphere. So, thank you all very much. Please reach out to me, send me an email, josh@josh.earth. I'm on Twitter, YouTube, like me in all the places. I always hear my son watching YouTube videos, and they always end with, okay, you guys, click like and subscribe. So click like and subscribe. And definitely message me on Slack if you have any other questions. I will be back in 1 week, where I'm going to do an Ask Me Anything about WebXR. So if you have questions about this, please come by there and ask me anything. Thank you all, and have a good week.